In this video, I'm going to show you how to use the chain rule. The chain rule allows us to differentiate composition functions. A composition function is a function that is dependent on another function. For example, f of g of x is a composition function, where g of x is substituted for x in f of x. F of x is dependent on g of x. To find the derivative of a composition function, we find the derivative of the outside function and multiply by the derivative of the inside function. So using this example, dy over dx is equal to f prime of g of x times g prime of x. Let's try an example. We'll start with the square root of 4x plus 1. We can rewrite this as 4x plus 1 to the 1/2 power. So what we'll first do is identify our outside function, which is going to be u to the 1/2 power. We'll then identify the inside function, which is 4x plus 1. Then find the derivative of each of these, which we find to be 1/2 u to the negative 1/2 and 4. You will then multiply these together. So we have 1/2 u to the negative 1/2 times 4. And then we plug in our u, which we found to be 4x plus 1, into u in our equation. So we have 1/2 times 4x plus 1 to the negative 1/2 times 4. And we can simplify this to be 2 over the square root of 4x plus 1. And this is our final answer. Let's try another problem. Find the derivative of 6 times 6x to the 10th minus 8x plus 8 to the negative 4th. So we're going to first identify our outside function, which is going to be 6u to the negative 4th. And then our inside function, which is 6x to the 10th minus 8x plus 8. We'll then find the derivative of each of these. Comes out to be negative 24 u to the negative 5th. And 60x to the 9th minus 8. And we multiply negative 24 u to the negative 5th times 60x to the 9th minus 8. And we can then plug in our u value, negative 24 times 6x to the 10th minus 8x plus 8 to the negative 5th times 60x to the 9th minus 8. And this is going to be our final answer. Let's try another example. Find the derivative of 2 cosine cubed x. This is not represented as this. It is this. So we can identify our outside value, 2 u to the 3rd, and our inside going to be cosine of x, and then we can find the derivative, 6u squared, and negative sine of x. And then multiply 6u squared times negative sine of x. Plug in our u value, 6 cosine squared x times negative sine x. And this is our final answer. We'll now attempt a problem with e. So in these problems, we kind of figure out that the solution is going to be e to the x times 1 over x. So we're going to use this example, e to the 1 over x. So the solution to this problem would be e to the 1 over x times the derivative of 1 over x, which we can use the quotient rule. We know is f prime of x times g of x minus f of x times g prime of x over g squared. And we will find that the derivative of 1 over x is negative 1 over x squared. So we then just multiply that value by e to the 1 over x. So the solution to this problem is going to be negative e to the 1 over x squared. We'll now attempt a problem with a natural log. So at these problems, we'll find that the solution is equal to 1 over the inside function multiplied by the derivative of the inside function. So using this example, we'll find that 1 over 4x multiplied by 4. And then we can simplify this to be 1 over x. And this is the final solution. Let's try another equation. 2 divided by 2 minus x to the 8th to the 3/2 power. So we can rewrite this as 2 times 2 minus x to the 8th to the negative 3/2 power. And then we can identify our outside value to be 2u to negative 3 over 2. And our inside is going to be 2 minus x to the 8th. We find our derivatives, which is going to be negative 3u negative 5 over 2 and negative 8x to the 7th. And we can multiply negative 3u to the negative 5 over 2 times negative 8x to the 7th. Plug in our u, negative 3, 2 minus x to the 8th, negative 5 over 2 times negative 8x to the 7th. And then we just simplify this, which will simplify to 24x to the 7th over 2 minus x to the 8th to the 5/2.